So far we have discussed how to find a complementary function. Now let us see how to find a particular integral. To find particular integral, again let us consider the equation a0 d power n plus a1 d power n minus 1 plus a2 d to the power n minus 2 plus etc. up to an whole thing into y is equal to q of x. This equation can be written as f of d into y is equal to q of x. Then the particular integral is 1 by f of d q of x. 1 by f of d q of x. This is a particular integral for the given equation. Now, based on q of x, we can get particular integral. That is, for some special cases, we have a formula. First, type 1. If q of x is equal to e power ax. If q of x is equal to e power ax, then what is d e power ax? I have already told you that capital D stands for d by dx. D e power x. That is, we have to operate d upon e power x. On operating d upon e power ax, we get a e to the power ax. That is, we have to differentiate e power ax. On differentiating e power ax, we get a into e to the power ax. D square, if you operate d square upon e power x, we get a square e power x. That is, when you differentiate e power x, first time we get a times e power x. Second time we get a square times e power x. If we operate d cube upon e power x, we get a cube e power x. That is, we have to differentiate e power x 3 times. First time we get a e power x. Second time a is a constant, keep a as such. Differentiate e power x, we will be getting a e power x. Already a is there, so we get a square e power x. Now differentiate a square e power x with respect to x. Keep a square as such. Differentiate e power x, we get a into e power x. So a square into a cube. A cube e power ax. Continuing in the same manner, d power n. If you operate d power n e power upon e power x, we get a to the power n e power x. On adding these things, we get d plus d square plus d cube plus etc. up to d power n into e power ax is equal to a plus a square plus etc. up to a power n whole thing into e power ax. So, but here it is a0 d power n plus a1 d power n minus 1 plus a2 d power n minus 2. That is, what is f of d? F of d is a0 d power n plus a1 d power n minus 1 plus a2 d power n minus 2 plus etc. up to an. Okay. So from this we get a0 d power n plus a1 d power n minus 1 plus a2 d power n minus 2 plus etc. plus an whole thing into e power ax is equal to e power ax is equal to a naught plus a1 to a square plus a2 into a cube get f of d e power ax is equal to f of a e power ax. Which implies that e power ax by f of a is equal to e power ax by f of b. That is 1 by f of d e power ax is equal to 1 by f of a e power ax, provided f of a is not equal to 0. F of a is not equal to 0. Therefore, particular integral is 1 by f of d e power ax is equal to 1 by f of a e power ax if f of a is not equal to 0. If f of a is not equal to 0. So type 1, if q of x equal to e power ax, then the particular integral comes out to be 1 by f of a e power ax, provided f of a is not equal to 0. In case of failure in the sense that if f of a is equal to 0, f of a is equal to 0 means a is a root of f of d is equal to 0. That is d minus a is a factor of f of d. So f of d can be written as d minus a into phi of d. D minus a into phi of d. D minus a into phi of d. So particular integral is equal to 1 by d minus a into phi of d e power ax. Let me repeat. If q of x equal to e power ax, then the particular integral comes out to be 1 by f of a into e to the power ax, where f of a is not equal to 0. F of a is obtained by replacing d by a in the expression f of d. If f of a is equal to 0, then it fails. F of a is equal to 0 tells us that a is a root of the equation f of d is equal to 0. That means d minus a is a factor of f of d. That means what I want to tell is that if f of a is equal to 0, a is the root of f of d is equal to 0, consequently f of d can be factorized as d minus a into phi of d. d minus a into phi of d. Now the particular integral becomes 1 by, actually what is particular integral? 1 by f of d e power ax. But f of d is factorized as d minus a into phi of d. So 1 by d minus a phi of d e power ax. So this is nothing but 1 by phi of a integral 1 by phi of a e to the power ax e to the integral e power minus ax into e to the power ax dx. That is, if you operate 1 by d minus a, we get this. It is a formula which is equal to 1 by pi of a e power ax, e power minus ax, e power ax gets cancelled, we get a integral dx, which is equal to 1 by pi of a e power ax, integral dx is x. That is, particular integral is x into 1 by pi of a into e power ax. X into 1 by pi of a e power ax. 1 by pi of a e power ax. Now, you consider this. Differentiate equation 1 with respect to d. We get f dash of d in the left hand side. Right hand side d minus a into pi of d. Keep d minus a as h. Differentiate phi of d, we get phi dash of d. Plus keep phi of d as h, differentiate d minus a, we get 1. Now put d is equal to a. If you put d is equal to a, we get f dash of a in the left hand side. Right hand side, first term is 0, second term phi of a. This is equation number 2. This is equation number 3. Substitute 3 in 2. We get particular integral is equal to x into 1 by f dash of e power x, provided f dash of e is not equal to 0. If f dash of a is 0, then again we have to do like this. The particular integral is x square to e power ax divided by x square 1 by f double dash of a e power ax, provided f double dash of a is not equal to 0. If f double dash of a is equal to 0, then again we have to apply the same procedure. So the next step you will be getting x cube 1 divided by f triple dash of a, third derivative of f of d at d is equal to a e power ax, provided f triple dash of a is not equal to 0. That is, third derivative of f of d at d is equal to a is not equal to 0. So actually what I want to tell is, if q of x is equal to e to the power ax if q of x is equal to e to the power ax, then the particular integral is equal to 1 by f of a e power ax if f of a is not equal to 0. If f of a is equal to 0, then particular integral is equal to x into 1 by f dash of a e power ax. That means differentiate the denominator f of d with respect to d and then replace d by a. So, and you have to multiply one x to the numerator, provided f dash of a is not equal to 0. Provided f dash of a is not equal to 0. Again, the case fails. That means if f dash of a is equal to 0, then you have to differentiate again the denominator with respect to d, and then you have to multiply one x to the numerator. Already x is there, it becomes x square. That means if f dash of a is equal to 0, then you will be getting x square into 1 by f double dash of a e power ax. If f double dash of a is equal to 0, then again you have to differentiate the denominator with respect to d and then replace d by a, and also you have to multiply 1x to the numerator. So particular integral is equal to x cube into 1 divided by f double dash of a e power ax if f double dash of a is not equal to 0, and so on. So this is how the particular integral is found out for when the right hand side of the given equation is e to the power ax. Now let us do some problems based on this. Problem number 1. Solve d square minus 5d plus 6 whole thing into y is equal to e power x. Solve d square minus 5d plus 6 whole thing into y is equal to e power x. Write down the given equation. Put equation number 1. The given equations d square minus 5d plus 6 whole thing into y is equal to e power x. It is a second order linear differential equation whose right hand side is e power x. The right hand side is of the form e power x. Solution for this equation is complementary function plus particular integral. Now let us find out complementary function. Already we have discussed how to find complementary function. So let us find out complementary function for this. For that you have to write down the corresponding homogeneous equation. D square minus 5d plus 6 whole thing into y is equal to 0. The auxiliary equation is consider the auxiliary equation is m square minus 5m plus 6 equal to 0. On solving this equation, it is a quadratic equation. Either you can go for factorization or minus b plus or minus root of b square minus 4ac divided by 2a formula. On applying that formula, we get minus b plus or minus root of b square 25 minus 4ac divided by 2a, which is equal to 5 plus or minus 1 divided by 2. 5 plus 1, 6 by 2, 3. 5 minus 1, 4 by 2, 2. So m1 is equal to 3, m2 is equal to 2. Complementary function, you have to be very careful. Here we should not write y. Whereas in the first set of problems, the right hand side happens to be 0, therefore particular integral is 0, that's why we have written y instead of CF. But here we should write only complementary function because it is not the final solution, it is a complementary function because right hand side is not equal to 0, so hence a particular integral is not 0. Therefore, CF is equal to C1 e to the power 3x plus C2 e to the power 2x. Let it be equation number 3. We must be very careful. Here we should write only complementary function. We should not write y. If you write y, then it's wrong. It is a complementary function. It is not a final solution. Final solution is complementary function plus particular integral. We are yet to find the particular integral. Now let us find out particular integral. To find particular integral, the procedure is 1 divided by f of d. Here f of d is d square minus 5d plus 6 e power x. What is the procedure to find particular integral when the right hand side is e power ax? Just replace d by a, provided the denominator is not equal to 0. That means f of a is not equal to 0. If f of a is equal to 0, we have to differentiate the denominator with respect to d, and then we have to replace d by a. At the same time, 1x should be multiplied to the numerator. Again, if the denominator becomes 0, again we have to differentiate the denominator. We have to replace d by a, and 1x should be multiplied to the numerator simultaneously. Again, if it becomes 0, we have to repeat the process till we get constant. Either constant or till we get non-zero value. Now here it is of the form e power ax. The value of a is 1. So replace d by 1. We get 1 divided by 1 square minus 5 into 1 plus 6 e power x, which is equal to 6 plus 1 7, 7 minus 5 2 e power x divided by 2. This is particular integral. So particular integral comes out to be e to the power x by 2. Now I want to verify whether this particular integral is correct or not. So how to verify? To verify particular integral, replace y by e to the power x by 2. That is d square minus 5d plus 6 into e power x by 2, which is equal to d square e to the power x by 2 minus 5d of e power x by 2 plus 6 e to the power x by 2, which is equal to, we have to operate d square upon e power x by 2. D square stands for differentiation 2 times. We have to differentiate e power x by 2 times. When you differentiate first time, you will be getting e power x by 2. Second time, e power x by 2. 1 by 2 is a constant. D of e power x by 2, 1 by 2 is a constant. D of e power x, which is equal to 1 by 2 e power x. So d square of e power x by 2 is 1 by 2 is a constant. D square of e power x, which is equal to 1 by 2 d of e power x, which is equal to d of e power x, which is equal to e power x. So 1 by 2 times e power x by 2 minus 5 into, when you operate d upon e power x by 2, you will be getting e power x by 2. You keep this term as it, 6 e power x by 2, which is equal to 1 by 2 is a common, we get e power x by 2 is common, we get 1 minus 5 plus 6. 6 plus 1, 7, 7 minus 5, 2, e power x by 2 into 2. 2 gets cancelled, we get e power x, which is the right hand side. So therefore, our particular integral is correct. What I want to tell us that if you replace y by particular integral, we have to get the right hand side. So we got it. So our answer is correct. Now let us write down the final answer. We know that the final answer is y is equal to complementary function plus particular integral. Complementary function plus particular integral. So therefore, y is equal to, what is complementary function? C1 e to the power 3x plus C2 e power 2x. What about particular integral? Particular integral is e power x divided by 2. This is by equations 3 and 4. Now let us do the second problem. Second problem, solve d square minus 60 plus 9 whole thing into y is equal to 3 times e to the power 2x. Solve d square minus 60 plus 9 whole thing into y is equal to 3 e to the power 2x. Write down the given equation. Given equation is d square minus 60 plus 9 whole thing into y is equal to 3 times e to the power 2x. Write down the auxiliary equation. The auxiliary equation is m square minus 6m plus 9 is equal to 0. Now let us solve this auxiliary equation. M is equal to minus b plus or minus root of b square minus 4ac divided by 2e, which is equal to 3, 3. 6 plus or minus 0 by 2, so m comes out to be 3, 3. The root 3 is repeated 2 times. Therefore, complementary function. Again, I am telling that here we have to write complementary function, we should not write y. Complementary function is equal to c1 plus c2x into e to the power 3x. Now let us find out particular integral. Particular integral is equal to 1 divided by d square minus 6d plus 9 into 3 times e to the power 2x. Since 3 is a constant, it can be taken out. 3 times 1 divided by d square minus 6d plus 9 e to the power 2x. Here the function is e power 2x, which is of the form e power ax. Here a is equal to 2. The procedure is d should be replaced by a. On doing that, we get 3 times 1 by 2 square minus 6 into 2 plus 9 e power 2x, which is equal to 3 into 1 divided by 9 plus 4, 13, 13 minus 12, 1. That is, particular integral is equal to 3 e to the power 2x. Therefore, the final solution is y is equal to complementary function plus particular integral. Y is equal to complementary function as c1 plus c2x, c1 plus c2x e to the power 3x plus 3 times e to the power 2x. Next problem. Problem number 3. D square plus 4. Solve d square plus 4 whole thing into y is equal to 3 plus e to the power minus 4x. Solve. D square plus 4 whole thing into y is equal to 3 plus e to the power minus 4x. Write down the given equation. D square plus 4 whole thing into y is equal to 3 plus e to the power minus 4x. Let it be equation number 1. The auxiliary equation is m square plus 4 is equal to 0. On solving this auxiliary equation, we get m square is equal to minus 4, m is equal to plus or minus 2i. Therefore, the complementary function comes out to be c1 cos 2x plus c2 sin 2x. c1 cos 2x plus c2 sin 2x. Now let us find out particular integral. Particular integral is equal to 1 divided by d square plus 4, 3 plus e to the power minus 4x. So in the right hand side we have two terms. So we have to be very careful. So let us operate 1 by d square plus 4 upon 3 plus e to the power minus 4x. On doing that we get 1 by d square plus 4 into 3 plus 1 by d square plus 4 e to the power minus 4x. Now the problem is how to find a particular integral for 3. The idea is 3 can be written as 1 by d square plus 4 3 into e to the power 0x. 3 can be written as 3 into e to the power 0x. e to the power 0x is 1. 3 into 1 is 3. So 3 can be written as 3 into e to the power 0x. Now let us substitute d is equal to a. Here what is a? A is equal to minus 4. So if you do that, you will be getting 1 divided by minus 4 the whole square plus 4 e power minus 4x. Which is equal to, here 3 can be taken out, 1 divided by d square plus 4 e power 0x plus 1 divided by, this is 16 plus 4 e power minus 4x, which is equal to, if you put d is equal to 0, we get 4. So 3 by 4 e power 0x is 1 plus 1 by 20 e power minus 4x. This is particular integral. Equation number 4. We know that y is equal to complementary function plus particular integral. So y is equal to, what is complementary function? c1 cos 2x plus c2 sin 2x. Particular integral is 3 by 4 plus 1 by 20 times e to the power minus 4x. 1 by 20 times e to the power minus 4x. Next problem, problem number 4. Solve d cube minus 6d square plus 11d minus 6 whole thing into y is equal to e to the power 2x. Solve d cube minus 6d square plus 11d minus 6 whole thing into y is equal to e to the power 2x. Write out the given equation. Given equation is d cube minus 6d square plus 11d minus 6 whole thing into y is equal to e power 2x. The auxiliary equation is m cube minus 6m square plus 11m minus 6 equal to 0. Since it is a cubic equation, we have to take the help of synthetic division. Let us go for synthetic division. To solve this cubic equation, let us go for synthetic division. Write down the coefficients 1 minus 6, 11 minus 6. What is the procedure? We have to look at the last term. Last term comes out to be minus 6. We have to list out the divisors of minus 6, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So the possible roots are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So let us try out 1. This question is always 0, 1 plus 0, 1, 1 into 1, 1, minus 6 plus 1, minus 5, 1 into minus 5, minus 5, 11 minus 5, 6, 1 into 6, 6. So the value comes out to be 0, therefore 1 is a root. Now let us write down the transformed equation. The transformed equation comes out to be m square minus 5m plus 6 equal to 0. On solving this equation, we get m is equal to minus b plus or minus root of b square minus 4ac divided by 2a is equal to 5 plus or minus 3 divided by 2. 5 plus 3, 8 by 2, 4. 5 minus 3, 2 by 2, 1. So m1 is equal to 1, m2 is equal to 2, 4. 5 plus 3, let me check. 5 plus or minus root of 25 minus 16, root 9. Root 9 is 3. 5 plus 3. Sorry, it should be 24. 24. 25 minus 24, 1. 5 plus 1, 6 by 2, 3, 5 minus 1, 2 by 2, 1. So m1 is equal to 1, m2 is equal to 2, m3 is equal to 3. The complementary function is c1 e power x plus c2 e power 2x plus c3 e power 3x. This is equation number 3. Let me repeat. The auxiliary equation is n cube minus 6m square plus 11m minus 6 equal to 0. In order to solve this equation, we have to take the help of synthetic division. Write down the coefficients 1 minus 6, 11 minus 6. Let us perform the synthetic division by 1. This portion is always 0. We have to perform addition. 1 plus 0, 1. 1 into 1, 1. Minus 6 plus 1, minus 5. 1 into minus 5, minus 5. 11 minus 5, 6. 1 into 6, 6, 6 minus 6, 0. Therefore, 1 is a root. Now, the transformed equation is m square minus 5m plus 6 equal to 0. M is equal to minus b plus or minus root of b square minus 4ac divided by 2a. So, 25 minus 24, 1. 5 plus or minus 1 divided by 2. 5 plus 1, 6 by 2, 3. 5 minus 1, 4 by 5 minus 1, 4. 4 by 2, 2. So, m1 is equal to 1, m2 is equal to 2, m3 is equal to 3. Therefore, the complementary function is c1 e to the power m1x, c1 e to the power x plus c2 e to the power m2x, c2 e to the power 2x plus c3 e to the power m3x, that is c3 e to the power 3x. Now let us find out particular integral. Particular integral is particular integral is 1 divided by f of d. Here f of d is d cube minus 6d square plus 11d minus 6 e power 2x, which is equal to 1 divided by, we have to replace d by a. Here a is equal to 2. If we replace d by 2, we get 2 cube minus 6 into 2 square plus 11 into 2 minus 6 into e power 2x, which is equal to 1 divided by 2 cube 8 minus 2 square 4, 4 6 are 24, 11 2s are 22 minus 6 e power 2x. Which is equal to 22 plus 8 30, 30 minus 24, 6 minus 6 0. So we get 0. So it is a case of failure. So particular integral. Here we denominator becomes 0. Therefore, in order to get the particular integral, we have to differentiate the denominator with respect to d. On differentiating the denominator with respect to d, we get 3d square minus 12d plus 11 e power 2x. So whenever we perform differentiation, we have to multiply one x to the numerator simultaneously. Okay, actually this is a case of failure. Now replace d by 2. We get x into 1 divided by 3 into 2 square minus 12 into 2 plus 11 e power 2x, which is equal to x into 1 divided by 1 divided by this is 2 square 4, 4 3s are 12 minus 24 plus 11 e power 2x. That is 11 plus 12, 23 minus 24 minus 1. So minus x e power 2x. This is the particular integral. This is equation number 4. Now y is equal to complementary function plus particular integral. Y is equal to, therefore y is equal to, what is the complementary function? Complementary function is c1 e power x plus c2 e power 2x plus c3 e to the power 3x plus particular integral is minus x e power 2x. Next, problem number 5, solve d square plus 2d plus 1. Solve d square plus 2d plus 1. Solve d square plus 2d plus 1 whole thing into y is equal to e power minus x. This is problem number 5. Write down the given equation, d square plus 2d plus 1 whole thing into y is equal to e power minus x. Equation number 1. The auxiliary equation is, m square plus 2m plus 1 is equal to 0. M square plus 2m plus 1 is equal to 0. On solving this, we get m is equal to minus b plus or minus root of b square minus 4ac divided by 2b, which is equal to minus 1 comma minus 1. 4 minus 4 0, minus 2 plus or minus 0 divided by 2. So minus 1 comma minus 1. So repeated case 2, actually belongs to case 2. Repeated real roots. Real and repeated. Complementary function comes out to be c1 plus c2x e to the power minus x. This is equation number 2. Now let us find out particular integral. Particular integral is equal to 1 divided by d square plus 2d plus 1 e to the power minus x. Here a is equal to minus 1. Replace d by minus 1. We get 1 divided by minus 1 the whole square plus 2 into minus 1 plus 1 e power minus x, which is equal to we get 1 divided by 1 minus 2 plus 1. So case of failure, denominator becomes 0. So it is a case of failure. So we have to differentiate the denominator. It is a case of failure, so we have to differentiate the denominator. On differentiating the denominator, we get 2d plus 2 in the denominator. When you differentiate d square, we get 2d. When you differentiate 2d, we get 2. So 2d plus 2 in the denominator. And whenever we perform differentiation, we have to multiply one x to the numerator simultaneously. So x into 1 by 2d plus 2 e to the power minus x. Case of failure. Which is equal to x. Now let us substitute d by minus 1. 2 into minus 1 plus 2. Again the case of failure. So again we have to differentiate. Particular integral is equal to 1 divided by differentiate 2d plus 2. When you differentiate 2d plus 2, we get 2 e power minus x. We have to multiply 1x to the numerator simultaneously. Already x is there, so it becomes x square. So x square by 2 e power minus x is the particular integral. There is no d in the denominator, so that's it. So x square by 2 e power minus x comes out to be the particular integral for this. Now y is equal to complementary function plus particular integral. Therefore y is equal to complementary function is c1 plus c2x e to the power minus x. Particular integral is x square by 2 e power minus x. Now the next problem is d power 4 minus 16 whole thing into y is equal to e power 2x. I think it's problem number 6. Solve. Solve problem number 6. Solve d power 4 minus 16y d power 4 minus 16 whole thing into y is equal to e power 2x. Write down the given equation. D power 4 minus 16 y is equal to e power 2x. It is a fourth order equation. The auxiliary equation is m to the power 4 minus 16 is equal to 0, which implies that it can be written as m square the whole square minus 4 square is equal to 0. It is of the form a square minus b square. We know that a square minus b square is a plus b into a minus b. M square plus 4 into m square minus 4. Which implies that m square is equal to minus 4 or m square is equal to plus 4. Which implies that m is equal to plus or minus 2y and m is equal to plus or minus 2. Therefore, the complementary function is c1 cos 2x plus c2 sin 2x plus c3 e to the power 2x plus c4 e power minus 2x. Now let us find out particular integral. particular integral is equal to 1 divided by d power 4 minus 16 e power 2x. It is of the form e power x, so the procedure is d should be replaced by a. On replacing d by a, we get 1 divided by 2 to the power 4 minus 16. 2 to the power 4 minus 16 e to the power 2x. 2 to the power 4 is 16. 16 minus 16 0. So case of failure. So in case of failure, we have to differentiate the denominator with respect to d. We get 4d cube e power 2x. 4d cube e power 2x. And we have to multiply on x to the numerator simultaneously. Now this is case of failure. This is equal to x. If you replace d by 2, you'll be getting 1 to 4 into 2 cube e power 2x, which is equal to x into 1 divided by 2 cube 8 4s are 32 e power 2x. Therefore, particular integral is equal to x by 32 e power 2x. Y is equal to complementary function plus particular integral. Complementary function plus particular integral. Y is equal to complementary function is c1 cos 2x plus c2 sin 2x plus c3 e power 2x plus c4 e power minus 2x plus x by 32 e to the power 2x. Now look at this. 1 by 4 d cube e power 2x. So we have just substituted d is equal to 2 and we got the answer. Another method is that we know that 1 by d stands for integration. 1 by d square, we have to perform integration 2 times. 1 by d cube means we have to perform integration 3 times. So this 1 by d cube this particular integral can be written as particular integral equal to x by 4 integration 3 times e to the power 2x dx. First time when we integrate this, we get e power 2x divided by 2. Second time we can take 2 outside, it becomes e power x by 8. Second time we get e power 2x by 2. We can take 2 outside, x by 16 integral e power 2x dx. Third time we get x by 16 e power 2x divided by 2. We get x by 32 e power 2x. The same thing we got it. It's up to you. Either you can directly substitute d is equal to 2 or you can do by this, because 1 by d stands for integration. 1 by d cube stands for integration 3 times with respect to x. And another point, here I have solved this equation like this. Even you can go for synthetic division to solve this equation. So now let us see how to solve this equation by synthetic division. M to the power 4 minus 16 is equal to 0. Write down the coefficients. What is the coefficient of m to the power 4? 1. n cube term is not there, 0. M square term is not there, 0. M term is not there, 0. Constant term minus 16. Now let us try out 2. 0, 1, 2 ones are 2, 0 plus 2, 2, 2 2s are 4, 0 plus 4, 4, 2 4s are 8, 0 plus 8, 8, 2 8s are 16. Now the transformed equation is m cube plus 2m square plus 4m plus 8 is equal to 0. So again we have to go for synthetic division to solve this equation. Let us perform synthetic division. What is the coefficient of m cube? 1. Coefficient of m square? 2. Coefficient of m? 4. Constant term? 8. So what are all the divisors of 8? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Since all the terms are positive, so we have to go for negative, we have to try out the negative values. So let us try out minus 1, 0, 1, minus 1, 1, minus 1, no, we won't get 0. 4 minus 3, 3, minus 3 it is 5, it is not equal to 0. Therefore, minus 1 is not a root. Then go for minus 2. 1, minus 2, 2 minus 2, 0, 0, 4 plus 0, 4, minus 2, 4, minus 8, 0. Therefore, minus 2 is a root. Now, the equation becomes, the next transformed equation is m square plus 4 is equal to 0, m square is equal to minus 4, m is equal to plus or minus 2. Same thing we got. The roots are plus 2 minus 2 plus 2i minus 2i. So it's up to you. Either you can perform synthetic division, otherwise you can factorize. D power 4 minus 4d cube. Is y is equal to complementary function plus particular integral. First let us find out complementary function. To find out complementary function we need a auxiliary equation. The auxiliary equation is m to the power 4 minus 4m cube plus 6m square minus 4m plus 1 is equal to 0. Let it be equation number 2. Now let us solve this equation. So it is a, what is the degree of this equation? 4th degree equation. So we have to go for synthetic division method. So let us perform synthetic division. Okay. Write down the coefficients. What is the coefficient of m power 4? 1. M cube minus 4, m square 6, m minus 4, constant term 1. Okay. Suppose term is missing, in the corresponding place we have to put 0. Okay. What is the last term? 1. So let us try out 1, 0, 1. 1 into 1, 1, minus 4 plus 1, minus 3, 1 into minus 3, minus 3, 6 minus 3, 3, 1 into 3, 3, minus 4 plus 3 is minus 1, minus 1, 0. Therefore, 1 is a root. Okay. So we got one of the roots. There are 4 roots. We know that nth degree equation has got exactly n roots. Since it is a 4th degree equation, so it should have 4 roots. We got 1, so we have to get the remaining 3 roots. Next let us again try out 1, 0, 1, 1, minus 2, minus 2, 3 minus 2, 1, 1 ones are 1, 1 minus 1, 0. Okay. So 1 is repeated twice. Then the given equation, I mean the auxiliary equation gets reduced to a quadratic equation, m square minus 2m plus 1 is equal to 0. So m is equal to minus b plus or minus root of b square minus 4ac divided by 2a divided by 2a. So which is equal to 2 plus or minus 0 divided by 2. 2 plus or minus 0 divided by 2. So we get 1 comma 1. Therefore the roots are 1 is repeated 4 times. 1 is repeated 4 times. Therefore the complementary function is a plus bx plus cx square plus dx cube into e to the power x. This is a complementary function. Now let us find out a particular integral. Particular integral is equal to 1 divided by d power 4 minus 4d cube plus 6d square minus 4d plus 1 into e power x plus e power minus 2x minus 4. So there are 3 terms. Okay. So this thing can be written as pi can be written as pi1 plus pi2 plus pi3, where pi1 is equal to 1 divided by d power 4 minus 4d cube plus 6d square minus 4d plus 1 into e power x. pi2 is equal to 1 divided by d power 4 minus 4d cube plus 6d square minus 4d plus 1 into e power minus 2x. pi3 is equal to minus 4 divided by d power 4, that is 1 divided by d power 4 minus 4d cube plus 6d square minus 4d plus 1 minus 4. So the entire thing can be taken as equation number 4. Now let us find out these things, pi1, pi2, pi3. So in order to get pi, we require pi1, pi2 and pi3. pi1 is equal to 1 d power 4 minus 4d cube plus 6d square minus 4d plus 1 e power x. Now which is equal to, it belongs to type 1. The procedure is we have to replace d by a. Here a is the coefficient of x, here the coefficient of x is 1, so d should be replaced by 1. On doing that we get 1 power 4 minus 4 into 1 cube plus 6 into 1 square minus 4 into 1 plus 1 e power x, which is equal to what do we get? 1 minus 4 minus 3 plus 6, 3 minus 4 minus 1 plus 1, 0. Okay. So if we put d is equal to 1, we get 0. So it is a failure case. What we have to do is we have to differentiate the denominator with respect to d. Whenever we perform differentiation, x should be multiplied to the numerator. X, let us differentiate this, 4d cube minus 12d square plus 12d minus 4 x. Now substitute d is equal to 1. We get 4 into 1 cube minus 12 into 1 square plus 12 into 1 minus 4 e power x, which is equal to 4 minus 12 minus 8 plus 12 plus 4 minus 4, 0. Again we get 0. Again failure case. So again we have to differentiate the denominator with respect to d. Okay. So please remember that every time when you differentiate the denominator with respect to d, x should be multiplied to the numerator. Already x is there, so it becomes x square. X square into 1 divided by 12d square minus 24d plus 12 e power x, which is equal to x square into 1 divided by 12 into 1 square minus 24 into 1 plus 12 e power x, which is equal to, Again we get failure. 12 plus 12, 24 minus 24, 0. Again we get 0 in the denominator. Again denominator becomes 0. So again we have to differentiate the denominator with respect to d. So we have to multiply one x to the numerator. Already x square is there, so it becomes x cube. X cube. When I differentiate the denominator, we get 24d minus 24. Now substitute d is equal to 1. Substitute d is equal to 1. We get x cube into 1 divided by 24 into 1 minus 24 e power x. So again denominator becomes 0. Again failure case. So again we have to differentiate the denominator with respect to d. So since we are differentiating the denominator with respect to d, x should be multiplied to the numerator. So already x cube is there, so it becomes x power 4. X power 4 into 1 divided by 24. When you differentiate 24d, we get 24. So therefore pi1 comes out to be x to the power 4 divided by 24 e power x. This is equation number 5. Now let us find out pi2. pi2 is equal to 1 divided by d power 4 minus 4d cube plus 6d square minus 4d plus 1 e power minus 2x. In this case the coefficient of x is minus 2, so we have to replace d by minus 2. So if we replace d by minus 2, we get minus 2 to the whole power 4 minus 4 into minus 2 to the whole cube plus 6 into minus 2 to the whole square minus 4 into minus 2 plus 1 e power minus 2x, which is equal to, what is minus 2 to the whole power 4? Minus 2 to the whole power 4 is 16. Minus 2 to the whole power 4 is 16. Minus 2 to the whole cube is minus 8. Minus 8 into minus 4 plus 32. Minus 2 to the whole square is 4. 4 6 are 24. Minus 4 into minus 2 plus 8 plus 1 e power minus 2x, which is equal to 1 divided by 32 plus 16 48, 48 plus 24 72, 48 68 72, 72 plus 8 80, 80 plus 1 81. So this is pi2. Therefore pi2 is equal to 1 by 81 e power minus 2x. This is equation number 6. Now pi3. pi3 is equal to 1 divided by d to the power 4 minus 4d cube plus 6d square minus 4d plus 1 to minus 4. So minus 4 can be written as minus 4 into e power 0x. So this thing can be written as minus 4 into 1 divided by d power 4 minus 4d cube plus 6d square minus 4d plus 1 e power 0x. In this case the coefficient of x is 0. So if you put d is equal to 0, if you put d is equal to 0, we get pi3 is equal to minus 4. If you put 0, d is equal to 0, 0 0 0, everything is 0 except the last one is 1. So we get minus 4. pi3 is minus 4. That is equation number 4 5 6 7. Now substitute equations number 5 6 and 7 in equation number 4. We get pi is equal to pi1, that is x to the power 4 by 24 e power x, pi2 plus 1 by 81 e to the power minus 2x plus pi3, that is minus 4. Therefore the general solution is y is equal to Cf plus Pi. That is y is equal to Cf. What is Cf? A plus bx plus cx square plus dx cube whole thing into e power x plus Pi plus x to the power 4 divided by 24 e power x plus 1 by 81 into e power minus 2x minus 4. This is from equations number 3 and 8 by equations 3 and 8. minus 15 d square plus 71 d minus 105 whole thing into y is equal to cos h to x. Write down the given equation. D cube minus 15d square plus 71d minus 105 whole thing into y is equal to cos h to x. The auxiliary equation is m cube minus 15m square plus 71m minus 105 is equal to 0. Now let us solve this cubic equation. To solve this cubic equation, we have to go for synthetic division. So let us perform synthetic division. Write out the coefficients. The coefficient of m cube is 1. Coefficient of m square is minus 15. Coefficient of m is 71. The constant term is minus 105. So we have to list out the divisors of 105. So let us enumerate the divisors of 105. The divisors of 105 are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7, plus or minus 15, plus or minus 35, plus or minus 105. So let us try out 3. 1 plus 0, 1, 3 ones are 3, minus 12, minus 36, 35, 3 5s are 15, 3 3s are 9, 10, 105, 0. So 3 comes out to be the root. The transformed equation is m square minus 12m plus 35 is equal to 0. M is equal to minus b plus or minus root of b square, that is 144, minus 4ac. 4 into 1, 4 into 35. 35 4s are 140 divided by 2a. 35 2s are 70, 70 2s are 140. Okay, fine. 12 plus or minus 144 minus 140 is root 4 divided by 2. So this is 12 plus or minus root 4 is 2 divided by 2. 12 plus 2, 14 by 2, 7. 12 minus 2, 10 by 2, 5. Therefore the roots are 3, 5, 7. Complementary function is c1 e to the power 3x plus c2 e to the power 5x plus c3 e to the power 7x. Now let us find out particular integral. Now particular integral is equal to 1 divided by d cube minus 15d square plus 71d minus 105 cos h to x. So far we have discussed only one technique, only one type, that is e power ax. So what I want to tell is, we know how to find particular integral for e power ax. But here the given function is cos h to x. So it has to be written in terms of e power ax. We know that the definition of cos h x is e power x plus e power minus x divided by 2. So cos h to x can be written as cos h to x can be written as e power 2x plus e power minus 2x divided by 2, which is equal to, this 1 by 2 can be taken out, 1 by d cube minus 15d square plus 71d minus 105 e power 2x plus 1 divided by d cube minus 15d square plus 71d minus 105 e power minus 2x. Now this is equal to 1 by 2. Let us replace d by 2. We get 1 divided by 2 cube minus 15 into 2 square plus 71 into 2 minus 105 into e power 2x plus 1 divided by d is replaced by minus 2. We get minus 2 the whole cube minus 15 into minus 2 the whole square plus 71 into minus 2 minus 105 e power minus 2x, which is equal to 1 by 2 times 1 divided by 8 minus 2 square 4, 4 15s 60, 71 2s are 142 minus 105 e power 2x plus 1 divided by minus 2 the whole cube minus 8 minus 2 the whole square 4 into minus 15 minus 60 minus 142 minus 105 e power minus 2x. That is equal to 1 by 2 times of 142 plus 8 150. This is 105 plus 60 165, in fact minus 165, 150 minus 165 minus 15, so minus 1 by 15 e power 2x. This is minus 1 by 68 142 150 210 310 315. So this is a particular integral. Y is equal to CF plus PI. Y is equal to CF plus PI. Y is equal to C1 e power 3x and C2 e to the power 5x plus C3 e to the power 7x plus 1 by 2 times minus 1 by 15 e power 2x minus 1 by 315 e power minus 2x. Next problem. Solve d square solve d square plus 5d plus 4 whole thing into y is equal to e power x into sin h to x. Let me repeat. Solve d square plus 5d plus 4 whole thing into y is equal to e power x into sin h to x. Problem number 9. Solve d square plus 5d plus 4 plus 5d plus 4 whole thing into y is equal to e to the power x into sin h to x. Write out the given equation. D square plus 5d plus 4 whole thing into y is equal to e power x sin h to x. Equation number 1. The auxiliary equation is m square plus 5m plus 4 is equal to 0. M is equal to minus b plus or minus root of b square minus 4ac divided by 2b, which is equal to minus 5 plus or minus 3 divided by 2. Minus 5 plus 3 minus 2 divided by 2 minus 1. Minus 5 minus 3 minus 8 divided by 2 minus 4. So complementary function comes out to be c1 e power minus x plus c2 e to the power minus 4x. Let it be equation number 3. Now let us find out particular integral. Particular integral is equal to 1 divided by d square plus 5d plus 4 e power x sin h to x. E power x sin h to x. As in the previous one, sin h to x should be written in terms of exponential function. We know that the definition of sin hx is equal to e power x minus e power minus x divided by 2. So 1 by d square plus 5d plus 4 e power x into 1 by 2 times e power x minus e power minus x, which is equal to, this 1 by 2 is a constant, it can be taken out of the operator, 1 by d square plus 5d plus 4. Just you take e power x inside, sorry, this is sin h to x, so it should be e power 2x, e power minus 2x. You take e power x inside, e power x into e power 2x is e power 3x minus e power x into e power minus 2x is e power minus x. This is equal to 1 by 2 times of 1 by d square plus 5d plus 4 e power 3x plus minus 1 by d square plus 5d plus 4 e power minus x, which is equal to 1 by 2 times, replace d by 3. On replacing d by 3, we get 3 square plus 5 times 3 plus 4 e power 3x minus, replace d by minus 1. Minus 1 the whole square plus 5 into minus 1 plus 4 e power minus x, which is equal to 1 by 2 times 1 by 3 square is 9, 9 plus 15 plus 4 e power 3x minus 1 divided by 1 minus 5 plus 4 e power minus x. Which is equal to 1 by 2 times, this is 9 plus 4, 13, 13 plus 5, 18, so 13 plus 15, 28. So this is e power 3x divided by 28 minus 1 by 2 times, this is a case of failure. 4 plus 1, 5, 5 minus 5, 0. So case of failure, so we have to multiply x to the numerator and then we have to differentiate the denominator. When you differentiate the denominator, d square plus 5d plus 4, we get 2d plus 5 into e to the power minus x, which is equal to e to the power 3x divided by 2, 28 are 56, minus 1 by 2 times x into, now replace d by minus 1, 2 into minus 1 plus 5, e power minus x, which is equal to e power 3x divided by 56 minus 1 by 2 times x into 5 minus 2, 3, x by 3, e power minus x. That is e power 3x divided by 56 minus x by 6, e power minus x. This is a particular integral. Equation number 4. Now, the solution is y is equal to CF plus PA. Y is equal to C1 e power minus x plus C2 e to the power minus 4x plus e to the power 3x divided by 56 minus x by 6 e power minus x.